Welcome to Lab 2, Lines of Charge. Introduction. The purpose or description of this lab is to produce a computational model of two charged tapes exerting an electric force on each other. This model will be used to estimate the amount of charge on each tape necessary to float one above another. The fundamental principles and preview of the results. The fundamental principles that we will use in this lab primarily Newton's second law, where force is proportional to mass times acceleration, with a gravitational constant as follows, and Coulomb's law, which describes the force in relation to the charges of the object. We will use superposition to find the distributed charge along the tapes, and we will use electric fields of the distributed charge models by the tape. And here is a preview of the result. Assumptions in the model. In this lab, we assume that each tape has the same amount of charge, equally distributed. We assume that this charge is evenly distributed along the tape, not a point charge as in the previous lab. And we will assume negligible air resistance and other friction that would be involved. The model is that each tape was represented by several small charges or segments, or small point charges with equal charge in order to find the charge of each piece using superposition. The assumptions that we made from Lab 1, and here's some information from Lab 1. We assume that tape acts as a point charge, that air resistance is ignored, and that both tapes have the same amount of charges. And here is the data from Lab 1 that will be used. And using this information, we input the information into variables in the code, and I was able to calculate the estimated charge to be 1.708. Here in the code I used the function to determine the electrical field of the charged particles, and here in this function I was able to use this to calculate the line charge for summing up the charges of the line. Here I am able to continue to use these functions to calculate the tape from the top tape and from the bottom tape, allowing us to receive this result, that the magnitude of the force is 1.962 times 10 to the negative third newtons, which leads us to a charge of 1.708 times 10 to the negative third coulombs when it's treated as a line charge. Possible sources of error in this experiment are errors in the programming of the online software. Another potential error could be round-off errors in the truncation of data. Another error would be that the charge was not distributed uniformly, or the charges on the tapes are unequal. And there are further potential errors in Lab 1, such as inaccurate measurements, interference, loss of or unequal charge, or other errors that occurred in Lab 1. What if and why? What if each of the tapes were a single point charge, like in the previous lab? Compare the estimated model. The two different models give us different data with a potential difference of 17%, a little over 17%. And why do these estimates differ? These estimates differ because the line charge offers a different measurement than the point charge, as it models the charges as distributed along the tape in a line instead of concentrated at a singular point. This would lead the line charge model to offer a more realistic solution. And thank you for watching my video lab.